You've probably seen them popping up in your social media feeds, right? These videos of robots. Sometimes they're falling over clumsily, other times they're doing these incredible acrobatics. And you might be thinking, okay, that's just a gimmick. But behind the scenes, the race to build truly functional humanoid robots has become one of the most intense, high-stakes bets in the entire tech industry. So which one is it? Are they just clumsy toys, or are we looking at the next trillion-dollar revolution? Well, the world's biggest tech companies are betting billions that it's the latter. Let's dig into the numbers, because they are staggering. Let's start with a number that's almost hard to comprehend. $1 trillion. That's what Elon Musk predicts will be the future annual revenue from Tesla's Optimus robot alone. I mean, forget about cars. For Musk, humanoid robots are the future of Tesla. And it is definitely not just Tesla. There's a startup called Fig AI, founded just in 2022, mind you, and it's already pulled in massive investments from Microsoft, Nvidia, Amazon, you name it. And get this, without even mass producing a single product yet, its valuation has soared to nearly $40 billion. That's insane. And this quote is why everyone is scrambling to get in on the action. The CEO of Nvidia, Jensen Huang, the guy whose company is literally powering the entire AI revolution, he believes that a massive breakthrough for robotics, a ChatGPT moment, is right around the corner. But hold on. To really understand the hype, we need to be super clear about what we're talking about here. This isn't your Roomba or some simple factory arm that just moves back and forth. The goal is something else entirely, a concept they call embodied intelligence. So, embodied intelligence, what does that actually mean? Well, the idea is to create robots that look and move like us so they can navigate our world, see what's happening, make decisions on the fly, and handle all sorts of complex tasks. The end game here? It's artificial general intelligence, building a machine that can basically do anything a human can do. Okay, so if the goal is that huge and all this money is pouring in, why don't we have these things everywhere already? Well, it turns out that building a true humanoid robot is governed by this fascinating and, frankly, kind of weird principle. It's called Moravec's paradox. And basically, what it says is that for a robot, everything is backwards. The stuff that's hard for us, advanced calculus, chess strategy, that's a piece of cake for a computer. But the stuff that is ridiculously easy for us, things we do without even thinking, like walking across a room, that is an absolute nightmare for a robot. I mean, this just flips our whole intuition on its head, right? Think about it. A robot can beat a grandmaster at chess, no problem. But the single hardest part of that whole process for the machine isn't figuring out the winning move. It's the simple physical act of picking up a chess piece without knocking over the whole board. So these easy human actions are really instincts that we've evolved over millions of years. For engineers, they break down into two massive challenges. First is movement. Just walking requires this constant, subconscious ballet of coordinating dozens of motors just to stay balanced. And second is touch, the ability to sense pressure and texture. And that's exactly why you see every single one of these companies in their demo videos making their robot pick up an egg. It's the ultimate final exam for the sense of touch. The robot has to be gentle enough not to crush it, but firm enough not to drop it. It's this incredibly complex calculation of pressure and feedback that our hands just do without us ever thinking about it. Okay, so mastering the physical world is one thing, but there's another equally massive hurdle. Teaching a robot how to generalize, how to learn. I mean, you don't just want a robot that can work in one factory. You want one that can adapt to any factory, and that requires data, a ton of it. Right now, there are basically two big schools of thought on how to solve this data problem. First, you have virtual simulation. You build these digital worlds, these matrix-like realities, and train the robot's AI millions of times, super fast. The problem? The simulation is never a perfect match for the real world. The other method, which is Tesla's big bet, is real-world training. You get perfect data, but man, it is slow and it is expensive. So these different approaches to solving the learning problem lead directly to the different strategies these companies are using to try and win the market. This is a true clash of the titans, and each one is placing a very different bet. First, you've got Boston Dynamics, famous for those incredible parkour videos. They're focused on high-end, specialized mobility. Then there's Tesla, leveraging its self-driving AI and car manufacturing experience to just hammer down the cost and go for the mass market. Fig AI is zeroing in on perfecting the hands and arms, dexterity, for factory work. And then you have companies like Unitree who are competing almost purely on price, just trying to make these things radically more affordable.
And honestly, that might be the final and maybe even the biggest hurdle of them all. The technology can be absolutely mind-blowing, but if no one can afford it, it just doesn't matter. Commercial success is going to come down to one thing: price.
And just look at this massive difference. A specialized robot from Boston Dynamics might set you back $300,000. But meanwhile, Tesla is aiming for a price point of just $20,000, and Unitree is already selling a basic model for under 15 grand. This is the price war. This is the real battleground.
So why is that $20,000 number so important? Because it completely flips the economic equation for businesses. At that price, a robot that can work 24/7 costs less than half of what a single human worker makes in 1 year in the US. That isn't just an improvement, that's the tipping point for mass adoption.
Okay, so let's put it all together. We've got the hype, we've got the mind-bending technical challenges, and we have this brutal price war. What's the realistic timeline here? When are we actually going to see these robots out in the world? Well, right now, they're pretty much all in labs and factory trials. Tesla is shooting for 2026 for mass production, which is very ambitious. But the general consensus among experts is that we're probably looking at a 5 to 10-year window before we start seeing humanoid robots begin to appear in more general roles in our society. So the robot revolution isn't happening tomorrow, but let's be clear, this is no longer science fiction. Within the next decade, this technology is very likely going to be a reality. Which leaves us with a final and I think pretty fun question to think about. When you can finally have one, what is the very first thing you'd ask your personal robot to do?